Hey there, tech enthusiasts! Today we're diving into the world of shell scripting. Ever wished your computer could do things automatically? Shell scripting is your magic wand. It's about giving your computer instructions in a language it understands. Imagine automating backups, renaming hundreds of files, or even building your own custom tools. That's the power of shell scripting. Don't worry, it's not as scary as it sounds. Once you get the basics, you'll be surprised how much you can achieve. Let's get started. Ready to become a command line ninja? Let's go! First things first, what exactly is the shell? In simple terms, the shell is the bridge between you and your computer's operating system. It's a command line interpreter, meaning it takes your commands and tells the OS what to do. You'll come across different shells like bash, zsh, and fish. Each has its quirks, but they share fundamental commands. Bash is the most common, so we'll focus on it today. Remember, the shell isn't just about typing single commands, it's about combining them into scripts. These scripts are like recipes, automating complex tasks and making your life easier. Your computer's file system is like a giant library organized with folders within folders. Imagine walking into a vast library where each section is meticulously categorized. Just like books are grouped by genres and authors, your files are grouped into directories and subdirectories. Think of it as a tree. The structure starts from a single point and branches out into various paths, each leading to different files and folders. The root directory is the base, and everything branches out from there. It's like the trunk of a tree, providing the foundation from which all other directories grow. Key directories like /bin, essential programs, /home, user files, and /var, variable data, are your landmarks. These directories serve specific purposes and help keep your system organized. For instance, /bin contains the essential programs your system needs to function. /home is where all your personal files reside, and /var holds data that changes frequently, like logs and temporary files. To navigate this maze, you'll use commands like change directory. The cd command allows you to move from one directory to another. For example, typing cd documents takes you to the documents folder. This is like moving from one section of the library to another. List files and folders in the current directory. The ls command shows you all the files and folders in your current location. Add L for detailed information. This option provides more details about each file, such as permissions, number of links, owner, group, size, and time of last modification. Show the current directory path. The pwd command displays the full path of your current directory, helping you keep track of where you are in the file system. Mastering these commands is like learning the streets of a new city. You'll be finding your way around in no time. Just as you would use a map to navigate a new city, these commands are your tools to efficiently explore and manage your file system. With practice, you'll become more comfortable and proficient, making your digital navigation as intuitive as walking through your favorite neighborhood. Knowing your way around the file system is great, but what about understanding the system itself? That's where system exploration comes in. Commands like and are your magnifying glass, shows disk space usage, use for human readable format, MB, GB, displays real-time system resource usage, CPU, memory. Press Q to exit. Reveals system information like kernel version and architecture. These commands are like peeking under the hood of your computer, giving you insights into its performance and settings. Section 5. Taming files and directories. Now let's get our hands dirty and manipulate files and directories. These commands are essential. Create an empty file. For example, creates a file named myfile.txt. Make a new directory. Try. Copy files or directories. Use. Move or rename files or directories. Syntax is similar to. Delete files or directories. Use with care, especially recursive delete. Remember, with great power comes great responsibility. Always double-check your commands, especially when deleting files. Section 6. Redirecting the flow I/O and expansion. Ever wanted to save a command's output to a file? Or perhaps you need to combine multiple commands to streamline your workflow. That's where I/O redirection comes in. It's a powerful feature that allows you to control the flow of data between commands and files. The greater than symbol redirects output to a file, overwriting the file if it exists. For instance, if you want to save the output of a directory listing, you can use lsoutput.txt. This command will save the list of files and directories to output.txt, replacing any existing content in that file. The double greater than symbol appends output to a file. This is useful when you want to add new data without losing the existing content. For example, echo new entry. Output.txt will add new entry to the end of output.txt. Pipes, represented by the vertical bar symbol, let you chain commands together, passing the output of one command as input to the next. For example, lsl vertical bar grep myfile lists details of files containing the word myfile. This can be incredibly useful for filtering and processing data on the fly. Wildcards like the asterisk and variable expansion with the $sign are your shortcuts to more efficient scripting. The asterisk matches any character, so rm*.txt deletes all .txt files in the current directory. Be cautious with this command, as it can remove multiple files at once. The $sign followed by a variable name expands to the value of that variable. For example, echo $user prints your username, which is handy for scripts that need to adapt to different users. Understanding and mastering these I/O redirection techniques can significantly enhance your command line efficiency. Whether you're automating tasks, managing files, or processing data, these tools are essential for any power user. So next time you find yourself needing to redirect output, chain commands, or use wildcards, remember these tips and tricks. They can save you time and make your workflow much smoother. Happy scripting, B. Section 7. Guardians of the Code Permissions. In the world of Linux, security is paramount. It's the bedrock upon which the entire system stands, ensuring that only authorized users can access, modify, or execute files and directories. File permissions control who can read, write, or execute files and directories. These permissions are crucial for maintaining the integrity and security of the system. Think of them as bouncers at a club. Just as a bouncer decides who gets in and who stays out, file permissions determine who can interact with a file and in what way. The R stands for read and allows viewing file contents. If you have read permission, you can open and view the file, but you can't make any changes to it. The W stands for write and permits modifying the file. With write permission, you can edit the file, add new content, or delete existing content. The X stands for execute and lets you run the file if it's a program. Execute permission is essential for running scripts and executable files. Use the lsl command to see permissions represented by a string like rwxrxrx. This string provides a detailed breakdown of the permissions for the file. The first dash indicates file type, followed by 3 sets of characters for the owner, group, and others. Each set of 3 characters represents the read, write, and execute permissions for that category of users. To modify permissions, use the commod command. This command allows you to change the permissions of a file or directory. For example, commod plus x script quote makes script executable. This means that the file can now be run as a program. To change ownership, use the chown command. This command allows you to change the owner of a file or directory. Understanding and managing file permissions is a fundamental skill for any Linux user. It ensures that your files are secure and that only authorized users can access or modify them. By mastering file permissions, you become a guardian of your system's security, ensuring that your data remains safe and protected. So next time you see a string of permissions in your terminal, remember the bouncers at the club and the crucial role they play in keeping your system secure. With the right knowledge and tools, you can confidently manage file permissions and maintain the integrity of your Linux system. Stay vigilant, stay secure, and keep those bouncers in check. Section 8. Taking Control Job Management. Ever started a long process and wished you could pause it or run it in the background? Job Control to the rescue. The command lists currently running or suspended jobs. The command brings a background job to the foreground. The command resumes a suspended job in the background. The command terminates a job. Use the job ID displayed by. These commands give you the power to manage multiple tasks efficiently, switching between them or stopping runaway processes. Section 9. Your shell, your rules, configuration. Just like you can customize your desktop, you can personalize your shell. Environment variables and configuration files are your tools. Environment variables store values accessible by programs, is a crucial one. defining where the shell looks for executable files. Configuration files like, for Bash, store your custom settings and aliases, which are shortcuts for commands. For example, add to create a shortcut for updating your system. Remember to source your after making changes using. Now your shell is truly yours.